All right, so we're going to go over different ways to use large language model using this brief video of 5 minutes. And so the large language models can be used in two ways. One is by generating the text response, and second one is by generating embeddings. Now, we there are many use cases of generating text response. For example, you can ask it to rephrase a text. You can say that here is my text or document, please rephrase it for simple language. You could use it for translation. You can say that here is my text in English, translate this to Russian. You can do it summarization. You can give it in the prompt saying that here is my document, can you summarize it? And then you can also, of course, use it for content creation. For example, you can say that generate a blog article on such and such topic, keep the tone like this. Now, there are many more use cases of text response. There are infinitely many. For example, you can ask it to create SQL query. You can ask it to, you can give it the entire database schema and ask it to solve a business problem. Say, tell me the sales that happened last year, and it will generate the SQL. And similarly, it can also generate all other programming language. If you have your own niche language and that ChatGPT doesn't know or large language model doesn't know, what you can do is you can take a parallel language and you can get the code generated in that language, and then you can translate in yours. The next is you can call the API. There's something called plugins that ChatGPT uses and large language model uses. You can use that one, but that one is subjected to change. It's subject to change. What is not going to change is generating, say, Python code. You can ask it to say that, okay, here is the API for my robot. Move left leg, move right leg, turn the head, and move forward, and so on. And here is the all the functions. Now generate the Python code to move the robot from point A to point B. And it would write the Python code for you to move from one place to another. Now that's a powerful thing about generating code. Once you are able to generate code in Python, you can run it inside a Docker container or something. And that makes it do all kinds of things. You can basically say take a big problem, ask the large language model itself to break it down into smaller parts, and then for each individual part, you can generate, say, Python code, SQL, or some other command. That way, you can achieve almost everything using the text response. Now, there is another very important way to large language models. That one is by using embeddings. Now, instead of asking large language model to generate an answer or a text or a response, you ask it to generate embedding. So what researchers realize that the embeddings are basically representing the meaning of a sentence. So you can take an input text, convert it to embedding using a large language model, and then you can use these embeddings as a vector. Say, canine companion, say, that is your input text and you're feeding it to large language model, say OpenAI and Gemini, they provide the API and the endpoints for generating embeddings, and they generate this bunch of numbers. Now, the cool part about embeddings is that there is a semantic relationship between the embeddings. Similar sentences would be represented by close by embeddings. Like, for example, here, canine companions say woof. This one, you see, this one is the canine companions say woof, that's close by to each other. And then the feline companions say mew, they are close by to each other. And bovine buddies say moo, they are closer to each other. Also, please note that these sentences are also close by. Now, but canine companions say woof is closer as compared to moo. Okay, so very important part is that the embeddings represent the semantic meaningfulness in the sentences, which if you plot them on the graph, they will look actually, they will make a lot of sense. While a sentence like quarterback throws a football, which is not related to all of these, is far away. Okay. So basically the things which are close by in the meaning usually come nearby when you plot the embeddings in a Cartesian system. Now let's take a look at the similarity part. Say, for example, what you do is you take a bunch of sentences and convert them into embeddings, and then you compute the distance between embeddings. And here is the similarity graph. So you can see here in the first column, okay, in the first column, I like my phone, and I like my phone, of course, is the darkest, which means there's the most similar one. My phone is not good, and I like my phone. You can see that one is very similar. So it's little less dark, but it's still dark. Then you can see your cell phone looks great, and I like my cell phone. That's again dark. But now see next one. Next one is, will it snow tomorrow? That one is very less similar to I like my phone. You see, it's very whitish. It's very, lighter color. Okay. This is essentially, we computed the distance between each pair of the sentences and put it into this bitmap where the higher number is represented by darker color, lighter number is represented by lighter color. I mean, the smaller number is represented by lighter color. And you can very clearly see the things that have no correlation in the meaning, they are brighter, right? Like, for example, what is your age? And I like my phone. And at the same time, if you try to find out about this, how old are you and what is your age? They are very close by. So very important part, the embeddings represent the meaning of sentences, correct? Which means similar things will have closer embeddings and dissimilar things will have farther embeddings. You can compute the distance between embeddings or this bunch of vector either using the standard Pythagoras kind of theorem, and we call that L2 distance or Cartesian distance, and or using the cosine distance, which is essentially the angle between the two vectors. And both the things work well in almost every large language model's embeddings. All right, now what can you do with embeddings? There are two ways to use the embeddings. First way of using embedding is using the software engineering things and say k-nearest neighbor. I don't call the k-nearest neighbor as machine learning because it's essentially a for loop where you try to find out what is closest to something or what are the closest neighbors to something. And essentially, using the k nearest neighbor, you can do many things. For example, say you have a lot of documents in your organization and you want to find out which document is closest to the keyword. So you compute the embeddings of the keyword and you compute the embeddings of all the documents and figure out which document is closest to the keyword that we are looking for. To make this process faster, to make the process faster of lookup, people use a dedicated store called vector store or vector database, which is designed to make the lookup based on embeddings really, really fast. Now, similarly, you can also search code based on embeddings. You give a small piece of code which you're looking for and compute its embedding. Then you basically look up in other embeddings which are close by to that particular embedding, and there you have the code search, which is code search based on the exact the meaning of a block of the code rather than the entire one. Then building a chatbot. You can build a chatbot using this technique. How? You can essentially do a semantic search first. Where is a particular question from the user found in our knowledge base? And then you can ask the large language model to generate an answer based on the particular sentence that you have found. Then you have knowledge base article recommendation, which is similar to semantic search, whereby when somebody types in a paragraph, you basically takes its embedding and find out the article having close by embeddings to that. Then you have the recommendation using embeddings. Say, for example, you know, ask, generate the embeddings of all the items based on the descriptions, and then you can essentially find out the similar items nearby the embeddings of a particular item. And similar to the users, you can represent the users as a bunch of embeddings and find out similar users based on the average of embeddings of all the products that they are using, or average of all the reviews they're using. Now, another thing is you can do the sentiment analysis. You can figure out whether something is positive or negative just by comparing the embeddings. Embeddings of, let's say, a review, embeddings of word negative and word positive. And that these essentially are few of the use cases of k-nearest neighbor using embedding. Now, the next very important aspect is to use a machine learning model or train a machine learning model. Say, for example, you could do supervised, unsupervised machine learning. Under supervised, you could do regression, classification. Let's walk through the regression. Like, for example, you have a database of reviews where you have review as well as the ratings. Okay, this is your sample or training data set. Now, what you want to do is, based on this, you want to build a system which can generate the ratings given a particular review. Okay, so you want to build a model in which you will feed a review and it will generate the ratings. Now, what you could do is you take all the reviews from your training data set, convert them via embedding. Via the large language model, you convert them into embeddings. Now you have, on one hand, you have embeddings, and you have on another, you have the ratings. Now what you can do is you can build your regression model using the embeddings, because regression models require your input data to be converted into numbers, and embeddings are a perfectly suitable thing for it. Now, regression you could build using any of the models and compare which one is doing well. The next use case could be the classification. So you have, let's say, lots of documents and you want to classify them into clothing, camera, home appliances. What you do is you take each of the document, convert that into, convert each of the document into embeddings and train a classification model to classify an embedding into a particular class. Then the other thing you could do is, say, clustering. For example, you have lots of customer reviews from the client. What you can do is you can compute the embedding of all the reviews. And then what you can do is convert all the reviews into embedding. And once you have embedding of all the reviews, you can reduce their dimensions to 2D and plot them. And that way, you will be able to see the clusters of reviews that this particular cluster is in. And then you basically, these particular cluster belongs together. They are similar reviews, and so on. And then you can basically create a hierarchical clustering or eliminate the cluster altogether and minimize the noise and keep only the valuable information. So this way, you can utilize embeddings to do a large amount of work. And you can build all kinds of systems using the large language models, either utilizing the text generation or utilizing embeddings or utilizing both of them together, and so on. So there are infinitely many possibilities of utilizing large language models to solve an industry problem. And that's why we have launched a very hands-on generative AI course with Langchain and Python. And we're going to walk through all these use cases in a very hands-on manner. This will be a 2 months blended course in which we'll take up multiple, more than 10 plus industry projects. And you will have the entire lab access where you will be able to do all of this. There'll be doubt clearing session during weekends as well as weekdays. And you will have the lifetime access to the materials, and you'll get a certificate from CloudX Lab. All right, so see you in my class on generative AI with Langchain and Python. It's a hands-on course, and we will cover the end-to-end of multiple such projects. Thank you.